Hey guys, welcome back. I'm talking to my good friend Mitchell O'Sullivan. We're talking about computational statistics, financial crimes, the way banks manage risk. Then we go into some physics and some philosophy of math and all the rest. All right, cheers, guys. All right, let's go. Welcome back, listeners. I'm talking tonight with my friend Mitchell O'Sullivan. He is how would you describe your field or your practice?
So,
Com-
so I'm in between, but my research experience is in computational Bayesian statistics and computational mathematics. My work experience is in analytics, reporting, and financial crimes detection.
a lot of interesting areas there. I mean, so much to go into. Like, what's your favorite part of all of that?
I think probably one of my favorite parts about the research is the high performance computing. So my favorite times at university were probably stressing the supercomputer as much as I can push it.
Yeah.
I like to process a lot of data to extract the most information, and I've carried that as much as I can into the workplace. But sadly, they don't have a supercomputer.
Yeah, yeah. See, I mean, there's a lot of practical components of that, and sometimes you don't really get that in those fields. It's more sort of theoretical, but like to have that sort of data, and that there's so much data there available.
That's right. Yeah, there's a lot, especially these days. It's being produced at an alarming rate and increasing. So how to handle that is a big and important question. So it's something that I'm working in because my research is around model calibration. So specifically, how to perform inference on the model parameters. I wouldn't say that it's models as large as some of those seen in deep learning or the cutting edge of
Yep.
machine learning, but at least in the classical sense, being able to describe the mechanics of a system, a stochastic process, using more freedom than you would traditionally be given, since you no longer have to worry about computational tractability. You can look at problems involving a lot of data
Yeah.
or with a lot of sophisticated hidden components that you need to understand.
I would say the bread and butter. Like it's really computational statistics. It's underlying all of machine learning, right? Like you can't. It's foundational to all of that. Um,
I would very much agree. It's there's a lot of there's a lot of parallels in some of the topics I come across when I was studying, and some of the problems I see that they have also been addressed in machine learning. So, part of my future research will be looking at ways I can incorporate some of that learning and see about whether it can improve my results. Since um, it's again trying to understand how a model can be most best adapted to the observed data.
Yeah. So can you run us through your what would you describe? I mean, your thesis topic, your passion, your interest at the moment, which is fitting, from my understanding, fitting data to a model.
Right. So my thesis was heavily algorithms focused. I predominantly was working in a toy model, which doesn't have very interesting applications, but that is going to change once I start my further studies as a PhD student. So when you have a model which you can't write down in just a closed form at all, the likelihood,
Yeah.
you need to use something called simulation based inference. So when you're sampling from the posterior in the Bayesian sense,
Yep.
you need to basically approximate the likelihood, and you can do that by using simulation. So when you have some candidate value in your prior, simulating data from the model and comparing the output to the observed process data can tell you something about how likely it was that parameter um, how likely that particular value of the parameters is to have, well, simply generated the data, and that tells you
Yeah.
about the posterior.
So that's more of sort of a generative model, right? Like because you're simulating or you're creating things. You're not just working off, doing straight inference on data. You're
So you Traditionally with like let's take a step back to the Bayesian approach.
Yeah, yeah,
Um,
good idea.
the prior your existing understanding about a model's parameters and the posterior being what you now believe given some observed data. Now, the likelihood is the critical component that relates them, since it tells you how an individual parameter value relates to the likelihood of observing some physical data. But if you can't compute that and weight each value of the parameter space, then you introduce an auxiliary variable, which is referencing the entire possibility of simulatable data, any real value that can come from the model.
Can you put this in like sort of a visual term in terms of like a fitness landscape or some sort of because I'm very visual sort of oriented. So like in terms of your model, what will that landscape look like? Does it depend on the data?
It very much depends on the data and even the model. It can vary quite widely. Sometimes it's just a nice unimodal distribution. It could be multimodal. There could be a lot of different parts you need to explore when you're trying to learn about it. It's not something that I have an immediate visual analogy for. I'm sorry. It's the kind of thing
Yeah,
that
that's
you,
right.
since it's simulations based, it's the kind of thing that you sort of you plot the real value on a graph, and then you sort of add a bunch of points onto it, and you take the few that are closest to your observed data,
Yeah.
and then those points are representative of simulation. So you look at the underlying parameter values that generated them, and then you take that sample as an approximation of the true posterior.
Okay. I mean, that you kind of lost me there, but sorry, you have to sort of slow this down for me, kind of thing. So, I mean, what sort of data are you looking at?
So some of the models I've seen are one is just a toy model, which is just a highly flexible normal type distribution. Another I've looked at is something to do with the displacement of toads and their movement throughout the nights. So
Oh,
the
like
data consists of, uh, you know, there's also a time component, but also a participant ID. So each toad is observed by GPS where it resides on each night.
really, like they actually have real world data of toads around with GPS.
Yes, yes, someone went and
Okay.
did that. I believe the data's from the UK. I'm sorry, I don't have the exact citation on me. But there's a beach of this particular population, and it was suitable because of the geography meant that they couldn't travel, um, to or fro from the shore, just along the shore. So you had one-dimensional data. It kind of helped to simplify things. But you have observations of the toad on day one, day two, and then maybe it disappears. They can't find it until day seven. So there's missing times in there, and
Yeah.
that can mean that in your probabilistic model, you need to understand, well, why was it at this point on day seven? Where could it have come from on day six? And then if it was there on day six, where did it come from on day five? And so you end up with a lot of summations upon summations that, exponentially go out of control. And you end up in a situation where you can't use traditional approaches. So that's an example of where the data, it corresponds to a real understandable physical process, but just by having missing or censored data, you don't have all the information you
I mean,
need.
like all this for toads, right? Like, is it like how would you apply this? Like, obviously, this can be I don't know generalized or put into other sort of scenarios.
So that particular model was looking at the tendency for a creature to return a toad to return to one of the existing nesting locations, or whether it would set up a new home overnight.
Okay.
They were looking at its overall displacement, and they knew that it would reside at either a new location or one that it had been to on a previous night. They were trying to figure out, based on this information, it's something called like the Levy flight hypothesis. It
Okay.
has to do with, it's like a Levy process is similar to a Wiener process in that it's the way you have random movement. But
Yeah. So that's what I'm thinking. It's not just a random walk, right? Like this is toads have some sort of like complexity in their behavior. And is that what they're sort of trying to figure out, sort of thing? Is it, but that in a general sense.
Yes, trying to understand the distribution of their movements, how far they're willing to travel, because the reasons for their travel, we won't know, but it could be for food, could be for mateship, but it's not normally distributed. So they're looking at a Levy standard alpha, I believe is the name of the distribution,
Okay.
trying to calibrate that model instead. And by doing so, there's a paper from, I don't know, the late 20th century talking about this hypothesis, saying that's the way that wild animals move. It's more fat tailed because they need to forage further
All
sometimes for
right.
food.
Okay.
And so this was an application of that to the toads. But since they had some censored data, it was an approach that lends itself to this type of modeling, because you can use hidden variables or auxiliary variables and sort of keep track of those data points as an additional parameter. But using the approaches from my area of approximate Bayesian computation, you can simply generate a bunch of data, and you only can compare the
Yeah.
ones you have at the time points But you effectively, in the infinite case, simulate every possible value in between. It's just that we don't have infinite time, so we end up with a bit of error.
A bit of error. I think that's where in lies the subtlety is the um yeah, but yeah, in terms of computing these things, if it's just sort of straight statistics, I mean, do you need like some big sort of hardware behind you, like GPUs and
Uh, excuse me. I haven't got a lot of experience using GPU for this type of work, but a lot of the models are, generally, since we're computing more than one simulation,
yeah,
they can be done independently. So it's the kind of thing that, depending on the operation, I'm sure you could put onto a GPU. High core count machines are also useful. So I used the supercomputer since I could just submit a bunch of different jobs
yeah.
in parallel. But
I suppose that's it. If it's like in parallel, if you're not doing like a lot of matrix transformations and things like that, is
it really depends on the way the simulation works. I am focused on the algorithm side of things. So I'm working with a population of particle samples from the prior, and I'm learning um, as the algorithm progresses.
yeah.
I'm dropping the ones that don't generate good data, and I'm resampling them from the areas that are more informative. And this process repeats, but since I'm concerned about how much information I can extract in how little time and how few computations, I use a model that's like instant to simulate from.
Okay, so this is what you're trying to get is like the most efficient sort of algorithm that's going to be able to find the and how do you evaluate that or validate that? Like you,
Well, there are obviously some other approaches. Like I mentioned earlier, you can just treat the missing data as a hidden variable and use a Markov chain over the entire space as well. But basically, with that toad model, I looked at some of the other methods and the results they got, and they're all generally in agreement. So that's one way. When I'm working on real data, I don't have the answer for. I'll just check if it agrees with someone else's approach. Um, but in my thesis, my undergraduate thesis, I just generated a bunch of data that I knew the real parameter values for, and then I sought to infer them and compare the mean of the estimates to the real value.
see, is it accurate though that like sort of generating data because sort of deep networks you can augment the data as much as you like, but it leads to some loss of fidelity. Like you can't. I mean, I think there was applications where people were using generative models to create like um, images of like galaxy clusters, and then using that generated data to train a classifier sort of thing. But you're sort of thinking at some point it's going to reach a you know a you know a certain point where it's not able to sort of go beyond what the data is in the data there sort of thing. So
Yeah, that's one concern, is that since I I'm purely working in a synthetic data set,
Mm.
that I'm confirming that my approach works for any particular random value that I've taken from a range that may not represent anywhere close to what you'd actually observe in the real world.
Yeah.
So I might say that this method that uses some special distance function works best against across the entire set of synthetic data, whereas this other model is less accurate. But really what's happening is that in all of the regions of the parameter space that are actually useful in the real world, the second model was better because the first model couldn't fit as accurately to those realistic values but was better in the edges.
Yeah.
So there is a risk that I'm not looking in the right places, but that's part of why I'm going to be continuing this area and testing the approach on some of the literature models.
Yeah. Yeah.
So the toads was one example.
But in the end, you're sort of left with like a distribution, right?
Yes, I end up with a sample from my posterior,
Yeah.
the ABC posterior, indicative that there is some approximation occurring. And I'll have a final tolerance value, for example, that describes how close I was able to drive my simulations to the true data.
And can you like so comparing distributions? Actually this is one thing I really wanted to get my head around, but I never really got time. Is like KL divergence sort of thing.
Mm-hmm.
Could you explain that to me? Because that's something I was like frustratingly like bang my head against the wall.
I can try.
It's
I
like cross entropy sort of stuff. Is it?
Look, I couldn't tell you too much about the information theory backing of it, but I was using distances between distributions in my research. I ended up using the Rényi alpha divergence,
Okay.
which is a class of divergences. So it sort of generalizes the Kullback-Leibler divergence if it's the limiting case as alpha goes to 1. I was working with the Bhattacharya coefficient, which comes from the Hellinger distance. So those are just like you can define a metric on a vector space. It just tells you the distance between two points. You can define a distance between a function space, and
Yeah.
the KL is just one of them that has certain nice properties. I think it obeys the triangle inequality or something like that. That's a nice property of a metric, but it's in the KL case as it relates to information theory. I think it has something to do with it escapes me
It's
actually.
fine. You're like you're throwing. Yeah. It's all escaping me right now. Yeah. I'm sort of getting what you're putting down, but I think I need a bit more sort of time to kind of work it out. But in terms of like a very layman sort of term of what you're trying to do in these spaces with these distributions, you're
So the algorithm I'm focusing on is sequential Monte Carlo, and so as the name suggests, there's a sequential or iterative component. I take
does that mean it's like time based or
it's one after the other.
yeah?
So I take an initial population of particles from my prior,
Mm.
and then I progressively update that population until it approaches the posterior.
Isn't that all Bayesian though? Like
Well, that's all sequential Monte Carlo.
oh okay
It's just
fair.
that the way in which I update them
Yeah.
corresponds to how well a simulation with a given particle, how well it agrees with the observed data.
Mm.
So that's the essence. Instead of using like importance sampling or something to update the particles, resampling according to some multinomial probabilities, I simulate and look at a distance, and if it's above some threshold, I throw it away, and if it's not, then I keep it for the next generation, and then I resample to replenish the population, and that's my new approximation of the posterior at a given tolerance level.
Okay.
It's a process where all I need to do is describe how a model should work. As long as I can simulate it, I can learn about it.
Yeah. Yeah. I think that's what area I'm fascinating is how can you simulate it, or to what sort of fidelity, or like you can create any sort of synthetic data you want, but like how does that match real world data? And what's the sort of pitfalls of that?
Well, there is an old saying that I use too much, which is that all models are wrong, but some are useful,
Yeah,
right? Uh, I don't have a lot of experience yet on Bayesian model choice or model discrimination, but you can obviously look at the total mean squared error or something, or look at the um, do some test on like the chi-squared, depending on what your data looks like,
yeah,
and figure out compared to some baseline, is this actually explaining something? Um, the beauty about Bayesian statistics is that you end up with some more readily interpretable parameter distributions. You're no longer dealing with confidence intervals and saying, I think that a parameter is this with some degree of uncertainty due to sampling error.
yeah,
You're saying, I think this model is what's happening.
yeah, yeah.
And according to the information I've observed, these are the probable values of my parameters, which can explain this data. So it becomes a credible interval. A bit of a nudge there at the frequentis, but
All right, yep.
it's it's literally saying
Is
under
that
this.
debate still going on? I remember my friend was a frequentist, and
Uh,
he was like in from like behavioral psychology sort of thing.
I'm not going to throw any shade and kickstart whatever's going on there. Um, I don't think there is any animosity between them. Just a bit of a joke.
I think yeah, it's a but people take it seriously.
Oh,
uh,
certainly. I'm sure there's some that might use it as a joke, and some that might misinterpret it. Excuse me. But yeah, so it's a good tool set, especially if you want to make certain claims about the way a model works. But you can do so even if the model's wrong,
yeah,
uh, as long as it might fit your. It might give you a particular highly confident, very low variance posterior, and you can talk as certainly as you want about them. But you do need to do some further analysis to confirm that the posterior predictive distribution, like what is the realm of data that is likely under your model, and whether or not that's anywhere close to what you've observed.
yeah. So I'm kind of interested to go into kind of the practical applications of this. Obviously, your background in financial crime, does heavy in data science. Is that the same sort of models, the same sort of simulations that you're running?
Well, in my experience, I haven't needed to call on this simulation based inference yet. I think that there's a lot of tried and tested statistical methods that can be used for anomaly detection and behavioral profiling and clustering and
So
just
are those the main sort of areas of that field? Anomaly detection is just sort of detecting fraud, sort of thing.
yeah. There's a few approaches you can look at it. Like one is the general approach of understanding how a customer would use their financial instruments and then looking at things that don't fall into the realm of expectation.
Yeah, yeah.
So you can set that up as an anomaly detection problem, like naive Bayes uh, sort of risk based estimation. But there are other less sophisticated methods that are widely used in practice. Just things like, has this card been used at this merchant before, and is it normal for this person to spend $1,000 in 2 hours?
Yeah, exactly. Right.
Things like that. There are a lot simpler models that work quite well,
Hmm.
at least to a tolerable extent in terms of loss at some of the major institutions.
So would these models be going into uh, to sort of automating just fraud prevention sort of things, or is it more just like detection and then um, being able to sort of enforce something, or be able to,
Well, just getting eyes on an account will help to detect and stop any further loss. It's it depends on the level of sophistication and the maturity of an organization. I've been through a few that one used all external products from the schemes, Mastercard and Visa,
Yeah.
to manage their risk assessments and a case management tool for assessing alert, it looks fine or it's not, pausing a card, that sort of thing.
Yeah.
And in some other places, they use pretty sophisticated software that can, well, I mean, effectively do the same thing, but allows you to implement more, have more flexibility in the way you write the alert mechanisms. So you have the full breadth of the SQL Server language. You can use substrings, you can use subqueries, and all of that nice stuff. But at the end of the day, you're still restricted by what you can do in SQL Server.
Yeah.
And at a major bank, you might expect they don't have a strong appetite for messing around on the production systems. And
Why not? Well, like, come on, that's where all the good data is, you know?
well, I mean, especially in some cases, the fraud system sits entirely separate to
Yeah.
the core banking platform. And so all the transactions are just mirrored into it. And then the alerts and operations team can assess them in their own time.
There must be, I mean, yeah, especially working on real world data, you know, because they'd have to scrub all the data for any sort of personal PIO, the like personal identified data, right?
I think
I
that,
always, I kind of ran into that problem a bit, especially with GDPR and stuff like that. Is there, I can imagine, especially working in like fin crimes, that there is like a lot of like bureaucracy and a lot of red tape that, especially dealing with like,
yeah,
you know, data vast, trying to collect vast amounts of data. Is that frustrating? Like, is there a lot of
there are definitely obstacles to performing the kind of analysis that you might
just give me the
might want.
data? Like,
Definitely, data governance is a very important part of it. Not just because of privacy relations, but just other corporate risk-based issues. Um, it's very valuable. It's people's personal information, and obviously, when someone gets a hold of it, then fraud can happen.
yeah, well, what
It's
you're,
a bit ironic that
yeah,
the thought that someone could be in the financial crimes team and then siphoning off that sort of information.
yeah,
Depending on, I mean, I guess perhaps the level of maturity, some of it might be obfuscated, but for the most part, there's a lot of responsibility that you have to be able to see full card numbers, for example.
yeah.
Obviously, there are some even more secret parts, like the CVV2 code and the CVC2 code on the back of your card that we shouldn't have visibility over. But
So, what sort of transactions are you sort of mostly looking at, though? Is it
I'm mostly dealing with card transactions.
okay? So
So
just credit
credit,
card,
debit,
but it goes into. I mean, I suppose that's the main one, but I mean, and now I'm sort of into crypto kind of thing. Do you see this sort of bleeding into that sort of world? Or I mean, obviously there are a lot of forensics already involved in there, and I mean, the beauty of it is that it's more traceable and it's more, there's more information there.
yeah, the information sharing, it sounds like it would be quite helpful in crypto. The nature of a public
Well,
ledger.
it's all public, right?
That's right.
That's it. Just go to Etherscan.
Sometimes it's there's only so much when I'm dealing with card payments. I have exactly what shows up in a payment message, the same as you get on your statement.
Yeah,
I
yeah.
don't know any more about that merchant or what they deal in, or even what website it was sometimes. And same with banking transfers, it goes to an account number and that's it. Crypto, on the other hand, it is a tantalizing thought that you might have a lot more information to go with it. I mean, some people wouldn't agree with that sentiment because the whole nature of a a wallet address is that that's all you know. But
Yeah.
whether or not
Well, I mean, a lot of full compliance, people have to do KYC these days.
exactly,
That's completely kind of ingrained, and it's hard sort of getting around that, especially if you're looking at the off ramps, and I suspect that's like the main area for forensics in that side. Um,
yeah.
that's not really an issue with credit cards, though, I suppose, because it's
Well, I mean, you don't get money out of a credit card. For example, well, not unless you're going to an ATM, but
Yeah.
that's you can't put money onto a credit card in general. So one of the ways I look at crypto is more so from an anti-money laundering perspective of it's going to be something that someone will use a stolen credit card to top up a wallet and then send it off into nowhere, or
Mm.
someone will fraudulently open an account with an exchange that provides cash out via your bank or an instant payments card or something, and then they'll load fraudulent funds into that wallet and quickly exchange them and withdraw them.
You know all the tricks, like working in
That's yeah,
the train.
that's my job. Yeah.
Uh,
So obviously we have some obligations under AML legislation to be monitoring all sorts of payments, whether it's to another individual or to a business, and what the nature of that business is, whether they
yeah,
conduct cryptocurrency based exchanges or whether they are another payments remitter, a gambler, that sort of thing.
yeah.
But I'm not as well versed in AML, CTF legislation or techniques. I predominantly focus on card data and
Yeah, so I mean that's the other thing is like sort of profiling people by their I
just
suppose their transactions, just their sort of behavior,
yeah,
and that's something that well sort of partly working on at the moment. It's not outside, but just sort of um, uh, if you're going for credit, um, applying for a loan, I'm just doing
yep.
that. Um, yeah, it's sort of fascinating to sort of think of the algorithms that they're sort of, or the models that they're sort of putting that through just your behavior, and you sort of think every day, when you swipe your card, you buy your sushi, or it's a Friday night, you buy
Yep. Ugh.
or a Wednesday or a Tuesday kind of thing,
Well, I
you
don't judge,
know.
but
But I mean, the machine does. That's the thing. We had we talked about sort of implicit biases in data sets
yep.
previously on the podcast. Like, yeah, do you think that sort of plays into any of these? Because are your I mean, I suppose it's completely removed from any kind of. You're just looking at the transactions, right? The metadata. Like you're not tying this with any kind of personally
Demographics.
identifiable demographics, any racial sort of
Well, there are a lot of tools available in the space. It's quite a mature and buzzing industry. There you can pay a major company to give you a racial estimate of someone based off of their name.
Yeah, see,
Um,
that also has this implicit bias sort of thing.
well, it's just another factor that you can use in your model, and whether or not
Whether that's
right, whether it has some bias or not
yeah,
is
yeah.
something to be mindful of. We are fortunate, at least in my position, that I'm not going to cause, well, hopefully not too much inconvenience for an individual that perhaps is wrongly flagged as suspicious.
Yeah.
They
See,
might
this is
have some inconvenience, but
that I think uh, that a lot of machine learning data scientists that have that complete removed,
mm,
the removal from the immediate, or just the immediacy of it. Like it's easy to sort of look at a model and look at the statistics, but when it comes down to the personal thing, and that's it. So,
yeah, it is obviously something that you should keep in mind. I create some proposed model or a rule, and I look at the false positive rate, how many mistaken or genuine transactions come through by accident,
yeah,
and I sort of, I do treat that as a number sometimes.
yeah.
I'm more focused on preventing the fraud,
See that?
which
Yeah,
is
especially you have that target, and you have to validate that, and I mean, at least that is a very it's either fraud or not. There's no
yeah,
gray areas there. Sort of.
yeah. Yeah, well,
Is there? I mean, I don't know.
well, there is scams which are
Yeah,
not technically fraud, but
just morally dubious sort of thing.
well, one of the common kind of problems we started to see was people buying free trials that end up in the little tiny disclaimer text, recurring billing for a much higher amount. If
Yeah,
it was $6 to ship it here, they may or may not receive it. They'll probably forget about it. They didn't know they agreed to pay 130 a month.
Yeah.
or a week starting a month from now. So we can create an alert for that. Generally, just understanding the type of merchant, and then we can decide this is definitely a scam,
Yeah.
and call the person, and they will just decide, no, I want this.
See, sometimes it's sort of, you sort of hear these things and you sort of think the amount of effort that they've sort of put into this. It's like if you
Oh,
legitimately put that amount of like energy and thought into a legitimate business, it's gonna.
oh, well, I mean, I wouldn't call it legitimate. I mean,
I mean, yeah,
some of
obviously
them,
most of it's the.
they're so dodgy sometimes. I've I've gone and they usually have the full domain name because they're trying to reduce disputes.
Yeah.
Most people will get the second charge, go and research what's happened.
Are these also? I'm interested in the sort of
Mm-hmm.
the geography of this. Like, are these local or is it usually like international sort of scamming?
This particular type, the subscription scam, will generally be overseas, like in the UK or Malta or something.
Yeah.
Uh, it's kind of like someone will rent a desk at some startup place and then get whatever necessary mail they need to have come into them, and then they'll never be seen again, but they can
Yeah.
still put that address on all the business filings, and so they look very legitimate to someone that wants to do a bit of extra research when they see this crazy offer.
Yeah. Yeah.
But in terms of where they're really located, I don't know. For all I know, they paid someone in the area to do all of that legwork. Maybe a student or criminal in general.
All right. Okay. But these
Um,
these are the sort of hidden variables, or these the variables that you can't see, or the like, because you're only
yeah,
given a certain amount of data, and then you have to infer, and
yeah,
there's no model that can sort of do that sort of inference of like assuming that they've got a.
yeah. We definitely don't, take a merchant name as it appears in a transaction and then have a model go and look on the website and check whether or not the address is a shared address or anything like that. No,
Yeah. Yeah.
we certainly couldn't do that in the time frames that we have to make a decision sometimes,
Okay.
in real time or even just before more fraud can occur, kind of thing.
Yeah. Yeah.
So that's the kind of research that you would do as an individual when you're looking at creating a rule for a particular type of category of merchant. You might see they have a common acquiring institution or they have a common category code, and they contain the word .com in their merchant name. So you would decide that any merchant like that under $10, that's less than 3 months old in your system, is worth alerting to or perhaps even declining. Um, that sort of thing. Um,
So, and how does that work? Is it like a global sort of blacklist of just bad, like,
it's up to you. How you as
but,
institution or team decide to implement it. You can do it.
and you're providing that sort of that information to, I suppose, like like banks and credit card
This
uh,
is all
companies.
in-house kind of approach.
Okay.
So when I'm in the fin crimes team and we see a new pattern show up in recent fraud, in our monthly reporting, for example, then the operations team might say to us that we've got a lot of chargebacks or disputes on transactions with these merchants. Can you look at creating a rule for that? And that will sort of lead us into that direction. We'll go and see what we can do to minimize the false positives and actually detect and stop, or at least bring to the attention of the cardholders the risks that are associated with continuing through that transaction.
Yeah. Yeah. Okay.
It's yeah, it's not the kind of area that has a lot of deep learning or machine learning or really sexy models happening right now. There's a lot of legwork that happens, and part of it is because things move slow when it takes 2 months to get code put in production.
Yeah.
Um, and part of it is the appetite in management to actually innovate and push the boundaries. And I can, I'm a little bit reassured to see that some institutions are moving in that direction because fraud is evolving and financial bad actors, at least in the financial space, are getting a bit more cunning. The trends will change over time as the security responds. It's a bit of a cat and mouse game, which
Yeah.
is a fun way to think of it. So there'll eventually be the need for that sort of thing, but right now, not everyone is necessarily, they're in that final state or where they'd like to be. They have things under control, and there are a lot of off-the-shelf solutions that are already an uplift in most cases.
So,
There's
yeah.
big
So
industry.
so do you like sell this as a product? Is it
I sort of work, like, personally. I'm doing contracting as a developer,
okay?
so I'm building out some of these systems and the models to suggest rules or to quickly extract data that you need for performing risk assessments on new trends or on lists of compromised cards, for example.
Is there like a tier? What's the so does it go like code green, code red, like like obviously it's not just fraud, not fraud. Like what sort of levels of likelihood and probability do you have?
Well, if you have a model that you think, and I'm using model generously, if you have a rule that works very well, then you might make it actually have the authority to block a transaction.
Yeah,
Anything that is blocked should be assessed and looked at by a human in most shops, but by shops I mean the fraud operations team. But if you're not super confident, then you can color grade the alert, or you can silently alert, and you need to build up a certain number of matching transactions. Um, it depends on sort of what amount of human resource you have and whether or not it's a 24/7 operation.
yeah,
Some places they don't have the luxury of 24/7 alert assessment, so maybe you put in some more aggressive rules at night, so that you can sort of protect yourself from too much loss, or put in some alerts that happen if a really big amount of suspicious transactions occur. Um, but I don't know if I'd say there's really a grading scale. For the most part, you need a human eyes to look at it, so that you can actually go in and stop a card, or you can put an exception in for someone for the next 10-15 minutes and make sure they get what they want done.
yeah.
It's it's a space that I think has a lot of room to grow, really.
See, I'm thinking crypto. I mean, crypto has a lot of room to grow, and it will like reduce a lot of these problems. I mean, the whole point of blockchain is solving these trust issues.
Mm.
The thing, obviously, you can't solve human, uh, just
I don't know if gullible is the right word, but susceptibility
yeah,
to
and human just sort of out to make a quick
trust and
buck, and
mm,
so yeah, but it can solve a lot of these these trust mechanisms, or it has the potential, it has the promise. That's
well,
just my little um uh quib, what is it? My promotion there.
yeah, I'm definitely going to have to start worrying about crypto more at some point, as it relates to financial crimes more so. But as a payment instrument, I am trying to stay relatively informed. But I couldn't tell you too much about the inner processes or any of the inner drama that might be occurring.
Yeah, well, I mean, it's still evolving. That's the thing.
Mm,
Uh, everyone, the whole thing is sort of building consensus of where the network is going to go, sort of thing. So it's sort of this evolving. And I mean, the thing is, it doesn't have the institutional backing to sort of sustain itself. If it needs to go through a bailout sort of thing, like,
mm.
I mean, a lot of like, this is actually an interesting area if we sort of talk about financial crimes in terms of like white collar sort of thing. I mean, because a lot of fraud that's happening
Yeah.
is just like the rorting of the economy by the banks that have the means and power to sort of pull those leverage. And I mean,
Yeah.
and that essentially is what decentralized technology is supposed to do, is eliminate that the centralization of power. Because I think you know when it comes down to it, these fraud is based on this abuse of power structures, and this abuse of
I should
authority.
I should really be able to tell you what the book says. It has something to do with, like, a person in power has an opportunity and a need that can lead to this sort of thing. Because there is obviously a broader space outside of just payment card fraud. There is the fraud that happens through dodgy accountants. There's the fraud that happens through, not lodging your tax correctly, or I mean, deliberately doing it wrong. I mean,
Yeah.
and
See
there's
that?
abuse
Yeah.
of grants,
See when I
everything.
sorry, when I hear like financial crimes, I just sort of think, Cayman Islands, sort of, like what was it, the Panama Papers and things like
Yeah,
that.
yeah.
Like,
Well, yeah, that's I think that's the pinnacle of it, perhaps. I mean, that's the best we know.
well, yeah, what we know, sort of thing. So this is why it's like the white collar. I mean, the ones that get away with it, the ones in power, or the ones able to get away
Mm.
with it, sort of thing.
Oh, there's been some egregious failures in the space over the past, 5 years, especially as it relates to AML and legislative obligations, like Combank and Westpac having large fines relating to failure of their systems to report transactions that require they do,
Yeah,
especially to the Australian monitoring body for transactions. AUSTRAC needs to be told about transactions from overseas or from above a certain threshold. And in I think Combank's case, they just didn't report anything above a certain value. And I think that was more of a process failure. But whether or not the fraud is deliberate or accidental, it's still a bad thing overall. Sometimes the consequences aren't just fat cats getting richer; it's people getting hurt, especially overseas.
yeah, definitely.
So
I mean,
it's
so that, yeah, that's where you can sort of see the real world consequences of this sort of.
yeah, and I mean they don't necessarily have an incentive to monitor these things. I think that the point you made about decentralization is kind of interesting, and whether or not, well, I guess how that will pan out, whether they'll experience any of the same issues around, well, for example, from the Royal Commission billing dead people for services that they can't possibly be rendered. What will be the analogy in the future for cryptocurrency of that?
Um, yeah, well, it's sort of strange to say. Ideally, it's sort of bulletproof. And this is the thing: the protocols are sort of updated, or semi regularly. They can be sort of continuously updated. So if there is a a loophole that people continuously exploit,
Hmm.
then you just update the 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 software, and maybe the hardware, right? Like, that's the beauty of crypto is if there is that sort of, fiat money can't really do that, or credit really can't sort of update itself. If there is like we can have these sort of third party things that, like stay as watchdogs, but fundamentally
Yeah.
the underlying structure and the framework of it is just sort of the same, and that's based on a trust that is already given, sort of thing. So that's the.
Yeah, it's just handing over money, whether it's physical or digital, and the existing the existing players, they are trying to make it as easy as possible so that they get you to do it more because they all take a cut every time it changes hands.
Yeah.
Um, but yeah, in terms of, I mean, I don't think there's the same analogy in as far as I understand it, in cryptocurrency. So I'm not sure how it would play out. I mean, there's a concentration of power in the big networks like Mastercard and Visa in credit cards and debit cards.
Yeah.
Um, so hopefully that's something that you have protection against with crypto. I'll have to wait and see. But
Yeah, I mean, there's always like 51% attack, but
yeah,
like, I
yeah,
mean, building consent, that's, it's not really feasible, kind of thing. I mean, yeah,
hope
I'm
not.
still, I'm still learning about this sort of stuff as well. So I'm still figuring out like the ins and outs. But no, kind of what I wanted to sort of like loop back on is originally just more your kind of love of math, sort of thing, and your sort of interest in it, because like you can tell when you're sort of talking about it, you're very engaged, and so I wanted to more talk about the aesthetics of it rather than the practical and
Hmm.
the and just the sort of academic, or the other.
Well, I'll certainly agree. It's beautiful. As you can see, I've got some fractals as my phone's wallpaper.
Okay, so Mandelbrot, was it?
This is the Julia set.
Oh, Julia said, yeah.
It looks very similar in certain regions. Jumping straight into fractals as an example of mathematical beauty is perhaps the easy approach, but whether or not it's beautiful because it resembles nature is another question.
Yeah,
I think sometimes the beauty of math is just the simplicity, in the sense that you have a set of axioms that you agree makes expressions, true, or makes them interpretable or logical.
yeah,
Um, and from that, you build up this whole complex set of theory that can describe, you know, deep learning or cryptocurrency or it's the foundations of computability. And
so are you into like number theory much? Like, foundational sort of stuff like uh is it
no,
uh
what is it? Zermelo theory, Zermelo Frankel set theory or something.
like pineal axons and like
Yeah,
ZY KY
I
KYC
think it's ZFC.
ZFC
Um,
like Gödel sort of stuff, right? Like just set
yeah,
because I'm more into the philosophy
yeah.
and the foundational stuff that deals mostly with sets and
Well, I'm certainly a I don't mean to cast any shade. I'm certainly a believer in mathematics,
okay.
um, and
But
that's to say I try not to think about it too much.
yeah, where's
I
your proof though?
I agree with the axioms, and I'll just use them. But I think it's a very interesting area to question the
Yeah,
foundations. And
yeah, yeah,
certainly, was it Gödel who did the incompleteness theorem?
yeah, yeah.
Yes, I should really know that. That
I mean, it was Gödel, but there was like a whole lot about that. You attribute it to him, but I think there was a lot of
yeah,
behind the
and
scenes as
just the
well.
consequences of that and what that means for mathematics, right? It's
Well, I mean, Turing as
problematic.
well. Turing's up,
Mm,
sort of work was mostly inspired by Gödel and also like Russell.
yeah, or was it? And also, I think Church is in there somehow.
Yeah,
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 with the lambda calculus. Um, oh, well, I mean, computability. That's another area of mathematics. Really opened up a lot of opportunities. But to answer your question earlier about like the really numbery basic, sorry, the really low level stuff, I'm not super tuned into. I did quite an applied study set at university, and that involved stochastic modeling and computational mathematics
yeah,
as it pertains to using computers to accurately solve problems. Just looking at, literally how does a computer do math?
yeah, yeah,
And how does error look like in a numerical solver, and ways of discretizing continuous systems so that you can evolve them through time if you can't solve them, that sort of thing. But mathematics as a whole, I think some of the beauty comes from just being able to describe the physical world and make sense of it, and that's part of its appeal to me. At least, helped to inspire me to work on it and continue to learn more about the way well, just I guess to me the way the world works.
yeah, yeah. And do you have like sort of an overarching kind of
Mhm.
philosophy of how the way works? Is it like a Bayesian sort of outlook, or
uh,
because a lot of people describe themselves like Bayesian, and
mm,
I mean, it's a very, it's very heuristic. It's very much just sort of saying, well, kind of like this, kind of like that, but it doesn't do any sort of fine grained sort of explanation or
I would like to think I am Bayesian in the sense that I have a belief, perhaps about something, but I can update it in the presence of observed data. And whether or not you'd call that a Bayesian approach or whether or not you'd call it a scientific approach,
yeah.
it's open to interpretation, I think.
But is there any other like broad sort of overarching philosophies of maths?
Yes. So I am not a huge fan on the variety of interpretations of quantum mechanics.
Oh, okay, yeah, we should go into this. Yeah, I love it. Like, what is your interpretation?
Well, unfortunately, I don't know enough about physics to have a very strong opinion,
Oh,
but
that's okay.
I
I know nothing, so it's
okay.
like we're I'm not going to lose tenure or anything, but like I can
Right.
we can speculate. We can.
I just really uh, I can't. I like to take the opinion of Einstein, who says that God does not play dice,
So
and
completely deterministic universe sort of thing.
well, I guess at its core, I would like to think that there is some determinism. Yeah, it's not fully random in the sense that you really can't. If you can describe the possible outcomes, then I sort of think of that as like a measurement error or an uncertainty about the process as it works. And if we can never get the accuracy we need to make it fully deterministic, that's okay with me. But I don't necessarily think that it means that you can say that's what's really happening.
So, like, Heisenberg's uncertainty sort of principle, like as a foundation of, like um, matter sort of thing. Do you think that, like, on a macro scale, has any sort of? Do you think in aggregate, like, that is insignificant? It's really just more deterministic from the Big Bang sort of pushing forward, and that's just entropy. Um, uh, by that, like, not playing dice and having
Mm,
um, that complete. I mean, yeah, the other sort of ways are like many worlds.
mm.
The Everettian kind of view.
Yeah, I don't necessarily uh, prescribe to the many worlds interpretation. I think it's yeah. Well, things start to fall apart when you ask me these sorts of
But I
questions.
mean, the thing is, it like
It's
has
more a
very
comfort.
it's very elegant mathematics. It's just everything's just a wave
Mm,
function. The universe is just a wave function, right? Like, it makes sense when you sort of think about it, but then like you like try to, our brains aren't concept. Like it's sort of like the universe trying to think about itself, right? Like if
well, yeah, we maybe the amount of information that can be held in a structure as small as our brain couldn't possibly comprehend something as gigantic as the universe, for
yeah,
example. It
yeah.
would collapse into a black hole, right? That sort of
Well, in the computable sense, I've sort of talked about this. If you want to sort of talk about it, like just um, and like neurology can be just sort of looked at as this computational sort of system, just like firing of synapses, and that like applies to has all the sort of mathematical limits as like the Gödel and
hmm.
the rest would put down, sort of thing. So then you're sort of thinking like that system trying to think of itself is inherently limited, and there's so much you can do. And
Well,
but I mean, okay, so yeah, that's the computable sense, but then
mm,
there's the complete uncomputable sense. So do you know like Kolmogorov?
Kolmogorov, yes.
Kolmogorov? I can't say Kolmogorov.
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 Hmm.
Kolmogorov complexity, I think, is.
Doesn't ring a bell. I only know him from the goodness of fit test.
Well, he did a lot of foundational works in statistics, actually.
Oh, you're right. Yes,
Yeah, so like I mean, I don't think it's really taught because he was
it's
Soviet.
it's too hard.
Yeah.
He did all the probability theory, like the sigma and the p and the f, and looking at ways to
Yeah.
build up those spaces. Yeah, it vaguely rings a bell.
But in terms of complexity, like I think this is like another sort of foundational kind of idea or philosophy kind of thing.
Hmm,
It's just sort of like it's like incomputable. It's just sort of the minimal description length of a computable idea. So if you have a problem, what is like the minimal amount of length that you would what would take to compute that problem? And you sort of run into the halting problem with that
hmm,
because it's not computable. There's no way in the future you're able to. It's like NP hard or whatever.
hmm.
Um,
Right. That sounds like we're bordering on information theory approaches. Like you're trying to describe it in the smallest possible way. It's like a compression
yeah,
problem.
yeah, exactly. It is a compression problem kind of thing. But like in terms of our way of understanding the world, you think we all the information is there, right? We're just trying to have this bandwidth of trying to putting it here.
Well, I mean, I certainly think it's possible for us to create, the final model and build the theory of everything. I think that will be attainable by a species. Um,
A species, maybe not humans.
or maybe not, but more so, I don't want to put a limit on when we will. Um, But
We were actually talking about Wolfram before, right? And
yes,
his sort of autonoma, cellular autonoma
yes, yeah,
theory of everything.
his work there. I mean, I think it's a remarkable feat of nature that you have the simple rules for a system to evolve, and yet you have such an observed complexity that can come about.
Yeah,
Um, Even the canonical example of Conway's Game of Life is, I think someone's shown it's Turing complete, right? I mean, there's all sorts of things you can do with it just by the initial setup or the but just with those
yeah.
two rules about the way the cells live and die.
So that's what you mean by deterministic, or God doesn't play dice, right? If your view. See, I actually have something to say about this. I think like the worldview that we know of, we have a lot of residue from Newtonian mechanics sort of basically put this in motion. Our sort of foundational ideas of causality, and that was mostly popularized by Hume. Like he was like the biggest Newton fanboy. And before that, like philosophers, really had like this sort of Aristotelian sort of view of causality, where it was like the four prime movers, and one of them was like, and you more dealt with like teleology and these other forces that were, it was kind of like mostly metaphysical, or dealing a lot with metaphysics, and most of the Enlightenment, and then positivism after that was removing that, but we still have that view of this sort of mechanistic universe that is, I think, the residue of both Newton and Hume, and that it just doesn't is not compatible with like quantum mechanics, and that the debate that we're having before is sort of a is kind of a hangover to that. It was never really resolved, right? Like,
I think part of the issue is my lack of understanding, but it feels nicer to imagine that there's actually a tiny little particle that we just can't
yeah,
measure.
what a tacticon or something,
uh,
tachycon.
I
It's
don't
like
know.
has faster than the faster than the speed of light sort of thing.
Maybe. I don't know. I think there's an idea which is called pilot wave
Pilot
theory,
wave. That's
and
like Bowman mechanics, right?
don't even know. I'm not even sure if it relates to exactly to where I'm finding an incongruence, but uh, I like the sound of that. It sort of describes what I think of is that there's actually a particle somewhere, and we're just sort of looking at
Yeah, it's like a
we're
hidden variables theory kind of thing.
yeah,
Like,
maybe it's in another dimension. I don't know, but I prefer to think that there is one true location for an electron in a cloud.
well, it like
I just can't imagine
it's
it's.
it's both there and not
I
there.
know we
Like,
don't know where it is, but I'm sure it is somewhere.
well, have you observed it? I mean, that's the thing to you.
Well, I mean, the problem is if I do, then people would tell me, well, that's just where it happened to be when the wave function collapsed. But I'm still, how could I ever prove them wrong and say, well, it was always there
Yeah,
or it was always going to be there?
yeah,
It's just that you didn't know that because it comes from the uncertainty principle, right? Like, if you know where it is right now, you don't know where it's going.
yeah,
So you don't know where it will be.
yeah,
It immediately falls back into, well, very quickly, it falls back into the same wave function of where it could be.
yeah,
But I still like to think that's just because we can't measure both.
yeah, and that's it. Like the mechanics of the wave function collapse is super
Oof.
fascinating. Like the
Yes.
double split experiment, and then there's also like Victor's friends sort of thing, where
Don't know it.
it's kind of like double split, but then like someone is observing the observer sort of thing,
Oh, right.
and like it gets in this chain of causality kind of thing.
It's perhaps it's part of the reason why it's so hard to reconcile the ideas that go on at such tiny scales, because at the macro scale they're not as obvious.
Yeah, so I mean, there's always this pushback about macro realism and the idea that in aggregate, the you're dealing with levels, orders of magnitude, and that any sort of quantum mechanics has absolutely no um, influence on just the tiniest level up. From going from like chemistry, like quantum to sort of atomic to but I mean, we don't know that. We we're implying it. We're doing heuristics based on general relativity. Basically, there's no unifying sort of theory that we have to say that these aren't compatible, and at some stage there'll be like this.
Well, that's one of the great problems in physics, right? Is unifying the theories for the very big and the very small. And we do have a few candidates, like in string theory and stuff like that.
Where's that got us?
Well, I couldn't tell you with any certainty. More dimensions, but I can't read the paper on string theory and make sense of it, so I'm not really one to dismiss it. I'll listen to the science as it comes through, and well, we still don't have the answer yet, but it's an interesting place to be. I think it's very hard, as you say, to make sense of those tiny problems in our real world. We have no issues about where something is. I can see and touch everything. I know where it's moving because it's not quantum. But once we start to understand the influence it does have on our life, perhaps that will make it more easily understood by people. I think maths is nice because you can count on your fingers. You can measure distances in 3 dimensions and understand your positions relative to things you see in the distance, etc. But the quantum world it's very
mysterious.
It's mysterious.
It is.
And
we don't have
hidden.
the answers, and this is like why it's so intriguing and
it's
frustrating.
Alluring, yeah.
It's like no one has the answers to the thing.
I envy some. I don't know if envy or jealousy is the right word, but boy, would I wish I could be at the LHC and CERN and just see it in the thick of it going on, right? But I mean, look, it's not just, we shouldn't put all our attention on the little guys. There's also what's happening out in space, right? That's a very interesting place in physics.
It'd be interesting to sort of know what sort of models they're working off, right? Like, I'm sure they got some crazy. I mean, they got the data, maybe like petabytes and petabytes.
Oh, absolutely, heaps.
Just be like trajectories and velocities.
Yeah, trajectories. I mean, I think there's at least one. What are they called? Like mass spectrometer, at least in the LHC, and they use those measurements to understand what particles were present during the impact, and then they sort of relate that back to what should theoretically be possible and what sort of energy levels would lead to that sort of decay or the sum of all of the particles that were observed.
Super fascinating. So I was going to also sort of say, I suppose we're talking more physics now. The relationship between math and physics. Math is because math is it's pure and it's like clean sort of thing, or at least it has this sort of foundation that you can rely on. Do you believe it's like really out there? Are you like sort of this realist, or are you sort of like an anomalist where you sort of believe it's socially constructed, or like what's your sort of opinion on its validity and its actual?
Well, I only know our system of mathematics, and I am quite fond of it. But just like you can count in base 10 or base 12 or base 16, like I can imagine that there are other systems which aren't too distant to it that might be used by other intelligent life forms, previous civilizations, who knows. But I do think it's a very pure science in the sense that it can be studied entirely in and of itself, about itself, by itself. It's very well contained in that regard. I think it's foundational to all of the other sciences. Physics is just applied math to the universe, and chemistry is just applied physics to particles, and
Yeah.
biology is, somewhere in between there, life happens. But math is still math. And even when you get into stochastic modeling, like where I'm working, and trying to understand the way that certain processes work that have uncertainty in their measurements or something like that, it's applied there, but the tools that make it valid or make it, I guess, logically consistent were all developed and completely agnostic to my application. So I sort of think of it, don't want to go too deep and say it's, separate to the universe or the real world, but it does sort of,
It does the job.
It's very self-contained.
And it's very, I suppose you match it up with the reality, and you can sort of see its like usefulness, and it's the truth of it in action.
It's like ephemeral because it can exist on its own, but the remarkable thing is it is accurate with the real.
Yeah.
And yet it is sort of something that we just exist in our mind.
Yeah.
But it's still just, it has roots in logic. I guess if you do the tree of, physics depends on math, chemistry depends on physics, etc. I think logic at a foundational level is the bottom, but and then
you have
philosophy, maybe.
well,
Whether you put that at the bottom or the top depends on who you ask. Yeah. But no, I really find math a very very tantalizing idea. It's certainly something worth thinking about. It's delivered a lot of gains for mankind, and has a lot of interesting problems to solve. I think you don't have to be a certain person to love math, but there's a certain satisfaction that we can all share in when you solve a problem, for example.
Definitely.
Figure out one little trick and make sense of it.
And just for the sake of it, the beauty in discovery and finding something out and then solving something, like that was not clear before, and then you kind of have that clarity.
Math, and there's a lot of people that have talked to this and probably more eloquently put, but it's the kind of thing that discovering math doesn't necessarily feel like discovering math. It's that you work on the solution to a problem and you don't necessarily realize that the importance of the way you've tackled it or the solution itself. But that's because when you understand something, it just makes so much intuitive sense.
Yeah.
But a lot of education in mathematics is about trying to make the person you're teaching understand the importance of what you're telling them, and why would you want to solve the problem like this. And then that's just so that they know immediately what to do when they see something unknown. But you left them alone for a long time in front of a blank page and say, figure this out. And not everyone knows how to get started. It's the kind of thing where if there was some global catastrophic event and just like 99% of the world died tomorrow, it would actually take a long time to rebuild math, even though we have all the books.
Exactly. Put a library of Alexandria when all knowledge was destroyed, or half the world's knowledge.
It's dark, but
okay.
It's amazing. It always makes so much sense. Like, why didn't I think of that?
Well, maybe we should try and wrap it up and have some final thoughts on a more positive note. So your love of maths, and then applying it and its usefulness, and
yep, and computational assisted mathematics as well, I think is a positive in my mind. The advent of compute has meant so much to the realm of mathematics, statistics and computational statistics especially. But if there's one positive thought, it's the idea that Moore's law means we're only going to get more power in our systems, and we'll be able to tackle bigger problems. And then there's the frontier of
that's if our
chip shortages,
semiconductor.
But on a positive note, like, what kind of problems will we solve in the future with more compute, and also with quantum computers? Different algorithms for that, and one day biological computers.
Yeah.
What will that mean? I think there's hope yet. But we'll have to wait and see. Hopefully they don't become self-aware.
Well, not if they're on our side. I'm all for that, but if they're not. All right, awesome. Well, thank you very much, Mitchell. It's been a pleasure.
Thanks for having me, Drew. It's
No worries.
been great.
All right, cheers.